Hello and welcome to Empowered Learning. This video is an example of how we use statistical tests such as the hypothesis test in order to support or reject claims made from a statistical study. In this example, we see that we have two fast food restaurants, Burger Stop and Fry World, and the claim here is that the mean amount spent at Burger Stop is more than or greater than the amount spent at Fry World. And so we're also given summary information about the standard deviation as well as the amount of data collected from each sample from both Burger Stop and Fry World respectively. And so at a significance level of 10%, meaning that we have 90% confidence in what we're testing here, we want to know whether we support the magazine's claim or not. And so the assumptions here are that the samples are random and independent and that the populations are normally distributed. Okay. Notice that the samples themselves are not normally distributed, but the populations are. And we're asked to complete follow. So the first thing that we need to do is, from this information, figure out what it is we're actually trying to make an inference about. In other words, to put it plainly here, we're taking two samples of two different populations so that we can make an overall inference or assumption about the populations of each of those. And in particular, we want to compare the populations of both the people that go to Burger Stop and Fry World. And so in order to figure out whether we're going to reject this claim or not, we need to identify what our claim actually is and how that relates to what we call the null hypothesis and the alternative hypothesis. These things are important because the null hypothesis is the hypothesis that we're going to use to either help us to reject the claim that's being said here from the magazine, or to fail to reject it, meaning to support it. Okay. So the first thing that we need to do is identify what it is we're actually trying to do. So I'm going to come in here and bring in a blank page here so that we can write some stuff down. So we're going to say the mu1 is going to equal the mean at Burger Stop, and mu2 meaning the population mean. We're going to say the mean at Fry World. Okay, so what we want to do here is basically say that the amount spent on average at Burger Stop is more than the amount spent at Fry World. So this is our actual claim. And I'm going to rewrite it this way because when we start to do our hypothesis test, this is actually how we're going to use it. But this is our claim. Also, we know that if this is our claim, then if the claim is not statistically true, then what we will have to say is that the mean amount spent at Burger Stop is less than or equal to the mean amount spent at Fry World. And of course, we can interpret that this way as well. Now, one of the things that's important to us is we need to know what is the null hypothesis and what is the alternative hypothesis. Simply put, we know that the null hypothesis will always be the hypothesis that has the equal signs in it. So in knowing that, since we have, for the second one here, mu1 is less than or equal to mu2, or population mean for Burger Stop is less than or equal to population mean for Fry World, this is going to be what we're going to call our null hypothesis. So that means our alternative hypothesis here will end up being what our claim is. And so that's the first couple of pieces of information that we need to know here. So I'm going to move this out of the way and now answer these questions. So it says identify the claim and state the null hypothesis and the alternative hypothesis, which is the correct claim. So first thing, we know that the claim here is going to be that the mean amount spent at BurgerStop is greater than the mean amount spent at Fry World. So we'll go ahead and select that. The next thing is, what is the null hypothesis and the alternative hypothesis? Okay, so let's look back at this again, and we see that the null hypothesis is going to be that the population mean at BurgerStop is going to be less than or equal to that at Fry World. Okay, so if we look at that, that would be this one. And we see that matches. And so the alternative hypothesis will be that we have that. So alternative hypothesis here, let's just make sure that matches. Yep, alternative hypothesis, and we said that that was going to be the claim. All right, so which is the null hypothesis? Well, looking here, we see that the null hypothesis, which hypothesis is the claim? Sorry about that. Which hypothesis is the claim? We know that the alternative hypothesis is going to be the claim. So we've already identified that. All right, so the next thing that we need to do is figure out what our critical value will be for our rejection region. And so for here, I'm going to sort of sketch a graph to kind of let you know what it is that we're actually looking for. And then from that point, we will go into StatCrunch, and I'll show you actually how to find this value. So the first thing we need to do is find this critical value. So let's talk about what the critical value is and what it represents, and then let's use StatCrunch to find it. So here, since we know that our samples are both under an amount of 30, we know that we're going to have to use a t-test, which means that we're going to have to find degrees of freedom and all that good stuff. But here is a quick sketch of what a t-distribution looks like. And if you notice here, it looks like we would have this particular rejection region. Okay. Now, when doing hypothesis test, we either have what's called a left-tailed test, a right-tailed test, or a two-tailed test. And so how you know which tail to do, a quick way to do that is to look at whatever your alternative hypothesis is and see what the inequality sign is, and that'll sort of tell you. So whenever your alternative hypothesis has a greater than sign to it, then you're going to have a right-tailed test. And one way I like to remember this is I'll see that the greater than sign is sort of pointing in the right direction. So that tells me that the rejection region needs to be to the right. Now, if my alternative hypothesis was, let's say, population mean of BurgerStop was less than population mean of Fry World, then it would go to the left. And then, of course, if I was trying to say whether it's equal or not, then that would be a two-tailed test. So that's how I know that my rejection region needs to be to the right. This T sub 0 or T sub C, depending on what textbook you view it out of, is what's called your critical value. And so here we want to know what is going to be this value on the T distribution at a certain probability level. And so for this problem here, if we look, we see that our alpha is at 0.10. Okay, so what that means for us here is that what we really want to find here is the T distribution amount when probability or the area under the curve here is 0.90. Okay, so that's what we're looking for. Now we're going to use StatCrunch in order to calculate this value for us. So you can come here and go to StatCrunch, and I'm going to get this here so I can fit it within the window. So the first thing that we want to do is go to Stat, then Calculator, and since we know that we have to do a t-distribution, we'll go down to t, and then from here, do you see how it gives us this portion in red here that's under the curve? That's the probability that we're talking about. So if you remember what I said earlier, we said that we needed to find out what the t value is going to be here when the area under the curve, or the probability, is 0.9. So when we see that here, do 0.9, and we're trying to figure out what that value is. And so the only other thing that we need to figure out is what the degrees of freedom are. So coming here, for this type of test, we know that to find the degrees of freedom, we need to take the number of samples in, well, number of data in the samples for the first and the second minus 2. Of course, basically meaning we're doing the normal degrees of freedom for a t-distribution and subtracting 1 from each of them. So in this instance, we know that we have a total of 25 from N1 and N2, and if we subtract 2, we just get 23. So that is what our degrees of freedom will be. So we'll go ahead and put in 23 as our degrees of freedom, and then we'll compute. And so we see that in this case, our critical value is going to be approximately 1.319. Okay, so we'll go ahead and put that in now. All right, so we'll go ahead and move the StatCrunch out of the way. And 1.319. Okay. And so the next thing we need to do is select the correct rejection region. And so if we look back here, I'm going to grab StatCrunch. Everything that is in the white here is going to be our rejection region. And that's the same as my other sketch here. Everything over to the right here is going to be in the rejection region. So here we know that for values that are going to be greater than 1.319, or t values that are greater than t sub 0, if we use that terminology there, then that would be what our rejection region would be. So here we should choose this one. All right, so now what we need to do is find our standardized test statistic. So in other words, depending upon the type of test that we're doing, we need to find out what our standard error is, and we also need to find our test statistic value. And so this is what we're being asked to find here. So again, we're going to use StatCrunch to do that. All right, so let's go ahead and bring in StatCrunch so that we can calculate this test statistic. So remember, we are doing a t-test. So we need to go to t-stats and then to-sample with summary. So we need to put in our information here. So we have 8.87 and 77 cents, as well as sample size of 17. We also need to put in the information about the second sample. So the $8.24 for the mean, 62 cents for the deviation, and 8 for the sample size. So here, if you remember from earlier, we said that our hypothesis test, the alternative hypothesis here is going to be that the population mean for Burger Stop is more than the population mean for Fry World. And so just to make sure that you remember that, that's what our alternative hypothesis was. So we'll come here and select greater than, and then from there we shall compute. And so you see here how we have 23 degrees of freedom. And if you look here, that was one of the things that we knew that we had to have. We also see that our test statistic is 2.01, for so on and so forth. And if you look here, if this is 1.319, then 2.01 is way in here. So we know that that's going to be well within our rejection region, okay? So that tells us that we're going to have to end up rejecting our null hypothesis. So we have this information here. So what we need to do is go ahead and record what our standardized test statistic is. And so this would be 2.019. I think that's what we'll use here. 2.019. And then from that, we need to decide whether to reject or fail to reject the null hypothesis. And again, we were well within the rejection region, so we will have to reject our null hypothesis. And so now at that point, since we have to reject our null hypothesis, and of course, our null hypothesis was that the mean amount spent at Burger Stop was less than or equal to the amount that was spent here. So we basically cannot support this. So we do have to end up supporting our claim. So we can't support what we see here because statistically it doesn't work out. So our claim here is actually something that we can support. So we know that at 10% significance level, we know that there should be enough evidence to support the claim of the magazine that Burger World, the amount that's spent in Burger World is more than at Fry World. And so that concludes this example. Hope this helped.